a quick video on the difference between two reflections. One is specular and one is diffuse. You might not know what the word specular means, but you certainly know what the word diffuse means. And if we look at these two reflections here of my desk lamp, right, you can see this one is capturing the detail of my desk lamp. It must be a nice, smooth, clean reflection, the way you would expect a mirror to reflect. This, on the other hand, is stainless steel, but it's been polished not perfectly. It's been sort of sanded, but not making a smooth finish. And you can see you can't really get much of a reflection in here at all. And it's not to say that it's not reflecting, but it's not producing an image in reflection. So let's take a look at what these things actually look like when we're talking specular and diffuse reflection. Right? So a specular surface is as perfect a surface as you could get. Right? So here's a nice flat line. All the normals would be coming straight out of it. And what that means is all the normals are perpendicular to each other. All right, so let's take a look at a ray of something coming in. In this case, a ray of light coming in. They all come in parallel with each other. Right? They all come in parallel with each other. That's not hard. And because the normals are also parallel, you don't need a whole heap of geometry to realize what the outgoing rays of light are going to look like. This is regular or specular reflection. So what are the outgoing rays of light going to look like? Well, I'll draw this quick. I think I can do that nice and easy. They're all going to be parallel with each other. And that means you'll see a reflection. So that's like a mirror. Well, then what does a diffuse reflection look like? Well, imagine what a diffuse surface would be like. There you go. Let's draw in normals. I think you'll see the point I'm making right away. These are normals. This is, I also consider, the best reason why we never measure angles with a surface. Because surfaces, waves are so tiny, surfaces, you have to look at the most tiny little bit of a surface. So if you just drew something and said, well, here's the surface, you'd be averaging it all out. Normals mean you don't have to average it all out. So I'm not going to have to draw too many in here to get you the idea of what's going to happen. Right? So we have all these lines coming in. All the lines of the light, I'm just going to skip a few here, are parallel coming in. Are they going to be parallel going out? Well, I think you can see right away they're going to be anything but parallel. If we have to make these lines in relation to the normals, there's an outgoing one. There's an outgoing one. How about that? That. That. So we're not going to have any image in this reflection at all. So this is a diffuse reflection. So when you look around, which is the most common type of reflection? Unless you're surrounded by highly polished surfaces everywhere, and thus see your image everywhere, which frankly would scare me, you realize that all of the surfaces around us are causing diffuse reflection. Sure enough, they're reflecting the light. Some of them absorb them to make colors, but they're reflecting the light out. But the surfaces don't allow an image to be seen. If you have a nice smooth surface like that, well, then you can get an image easily in it. But that surface, down to a microscopic level, has to be smooth enough so the normals are all parallel to each other. If the normals are all parallel to each other, well, the law of reflection always holds, angle in equals angle out, then all the light rays coming out will be parallel with each other. If the normals are not parallel with each other, angle in equals angle out means even though these lines coming in are all parallel, because the normals are not parallel, the lines going out are going to be a positive mesh. Regular reflection or specular reflection and diffuse reflection. You heard it here. Thanks much.